Okay, let's look at this division now. 2x cubed plus 8x squared minus 16x minus 11 divided by x plus 2. Not left myself as much space there, but never mind, we can squeeze it in. Okay, x into 2x cubed is 2x squared. Multiply this, 2x cubed plus 2x squared times 2 is 4x squared. Subtract. That disappears. 8x squared take away 4x squared is 4x squared. Bring down the rest. X goes into 4x squared, 4x. 4x times that is 4x squared plus 8x. Subtract. Minus 16x take away 8x is minus 24x minus 11. X into minus 24x is minus 24. Minus 24 times that is minus 24x. Minus 24 times 2 is minus 48. And then final subtraction, the x's cancel. Negative 11 plus 48 is 37. Right, so we have a problem here then. It doesn't go exactly. It leaves a remainder. Now sometimes you are simply given the question like this. Find the remainder when that is divided by x plus 2. And you could do it that way, and the answer is 37. But fortunately there's a much easier way of doing it. Because if we put this equal to function of x, and let's try our tactics that we used with the factor theorem, then because I'm dividing by x plus 2, the value of x that I would want to put in would be negative 2. So if I put negative 2 into here, I get 2 times negative 8 plus 8 times 4 minus 16 times minus 2 is plus 32 minus 11, which is minus 16 plus 32, and 32 is 64. Take away 11 and yippee, it comes to 37. So that's good, isn't it? Because it saves me all of this division process, and so I can state the remainder theorem. And the remainder theorem is RT if a polynomial f of x is divided by f of a, I don't mean that, let's try and get it right, divided by x minus a, then f of a is the remainder. Now, of course, if you just think carefully for a moment, we could have taught the factor theorem the other way round. This is not a proof, by the way, this is a demonstration, and the proof, again, we'll do later on, is a little bit more complicated. But of course, what this is saying is that if f of a comes to 0, there is no remainder. And therefore, x minus a has to be a factor. So the factor theorem actually follows on from the remainder theorem rather than the remainder theorem following on from the factor theorem. So one way of teaching this topic is to do the remainder theorem first and then to look at the factor theorem.
so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.